The economics of automation in manufacturing. Introduction. Automation in manufacturing refers to the use of control systems such as computers or robots to perform tasks traditionally carried out by human workers. With the advent of advanced technologies, industries around the world are increasingly turning to automation to improve efficiency, reduce labor costs, and maintain competitiveness. As automation becomes more widespread, its economic implications are far-reaching, affecting everything from job markets to productivity growth and supply chain dynamics. While automation holds promise for boosting efficiency and driving economic growth, it also brings challenges, including labor displacement and the need for reskilling workers. This paper explores the economics of automation in manufacturing, focusing on its benefits, costs, and the broader economic consequences for industries and workers. Number 1. Defining automation in manufacturing. Automation in manufacturing involves replacing manual labor with machinery or technology to perform repetitive or complex tasks more efficiently and accurately. This can include everything from assembly line robots and CNC machines to AI-powered systems that optimize production schedules. The goal of automation is to increase productivity, reduce errors, and lower long-term costs associated with human labor. Application. Car manufacturers like Toyota and General Motors have implemented robotics and AI in their assembly lines, dramatically increasing production efficiency and reducing the risk of human error. Number 2. Historical background of manufacturing automation. The history of automation dates back to the Industrial Revolution, which saw the introduction of steam-powered machines that began to replace manual labor. However, the rapid expansion of automation in the manufacturing sector began in the late 20th century with the development of programmable logic controllers, PLCs, industrial robots, and more recently, AI and machine learning systems. These advancements have transformed manufacturing processes and continue to evolve with the development of new technologies. Application. The introduction of robotic arms in the 1960s revolutionized industries such as automotive manufacturing by automating repetitive tasks which were previously time-consuming and labor-intensive. Number 3. Drivers of automation in manufacturing. Several factors have driven the adoption of automation in manufacturing. Among the most prominent are the need for higher productivity, cost reduction, improved product quality, and a desire to remain competitive in a globalized economy. Automation allows manufacturers to increase output while reducing the variability of production and improving the consistency of products. Application. In the electronics industry, companies like Apple and Samsung use automated assembly lines to ensure high-quality production at scale, where human workers are replaced by robots in tasks such as circuit board assembly and testing. Number 4. Benefits of automation. The economic advantages of automation in manufacturing are significant. Some of the primary benefits include increased productivity. Automation allows manufacturers to operate 24/7 without the constraints of human labor schedules. Machines can work faster, more consistently, and without breaks. Cost reduction. Automation reduces the need for human labor, which can lower wages and benefits expenses, reduce training costs, and minimize the risk of human error. Improve product quality. Machines and robots can produce goods with precision and consistency, reducing the rate of defects and ensuring high standards of quality control. Safety. Automation can take over dangerous tasks such as heavy lifting or working with hazardous material, thus reducing workplace injuries. Application. In the automotive industry, companies like Tesla and BMW have used automation to cut production costs and improve vehicle assembly times, resulting in better margins and faster delivery to the market. Number 5. Costs of automation. While automation provides numerous benefits, it also comes with significant costs, particularly in terms of initial investment and ongoing maintenance. The upfront costs of purchasing and implementing robotic systems, AI technology, and specialized equipment can be prohibitively high, especially for small and medium-sized enterprises. Furthermore, companies must also invest in training staff to work with these technologies, as well as in maintaining and upgrading automated systems. Application. The implementation of robotics in the assembly line requires substantial capital expenditure, as seen in industries like electronics, where companies must invest in precision robotics, software, and factory reconfigurations to improve efficiency. Number 6. The role of labor in automated manufacturing. One of the most significant impacts of automation in manufacturing is its effect on labor markets. As machines replace human workers in certain tasks, there is often a reduction in the demand for low-skilled workers in manufacturing. However, automation can also create new opportunities for skilled workers who can design, maintain, and operate the machines. Application. In the food processing industry, automation has replaced workers in repetitive packaging tasks, while simultaneously increasing demand for engineers and machine operators to manage robotic systems. Number 7. Job displacement and labor market shifts. One of the primary concerns with automation is the potential for significant job displacement. Workers who previously performed routine manual tasks may find themselves out of work, especially in industries with high automation adoption rates. The displaced workers often face challenges in re-entering the labor market without new skills or education. Application. In the manufacturing sector, the rise of automation and robotics in countries like China and Mexico has led to job losses in low-wage, low-skill positions in factories, while jobs in areas such as machine maintenance and programming have increased. Number 8. Reskilling and upskilling the workforce. As automation displaces certain jobs, there is a growing demand for reskilling and upskilling initiatives. Workers must be trained to perform more complex and technologically advanced tasks, such as programming robots, monitoring automated systems, or maintaining machinery. Investment in education and vocational training programs is crucial to preparing workers for the changing nature of manufacturing labor markets. Application. Governments and private companies are increasingly investing in workforce development programs. For example, the German government has implemented vocational training programs to help workers transition into roles that require more advanced technical skills. Conclusion. The economics of automation in manufacturing is a complex and evolving subject